This is too close to the screen. I don't know.
I think you're good.
Yeah?
Yeah, we tested it earlier.
All right. Okay, I think we're going to get started. All right. Welcome, everyone. For those of you who don't know, the CLF is the Carbon Leadership Forum. We're the local hub here for Toronto. What do? We organize events to empower industry professionals to radically reduce embodied carbon from buildings and infrastructure. We're one of 30 local hubs across the world, and there's 3 in Canada, here in Toronto, Vancouver, and Ottawa. And if you'd like to hear more about who we are and our events and stay in touch, please visit our website, clftoronto.com, and sign up for our mailing list. Make sure this works out. There we go. Zoom. As a Toronto-based group, we acknowledge the land we are meeting on as the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis peoples. We also acknowledge that Toronto is covered by Treaty 13 with the Mississaugas of the Credit. So, I can get on. For the people online, we're going to take questions in the Zoom chat along the way. We recommend using speaker view. We recommend also that you put your audio and video off to help the bandwidth. And of course, the session is being recorded and will be on our website after. All right, so we're here today to talk about low carbon now. I'm going to do a brief introduction and then introduce the speakers. They really to speak about why this is really important and timely. So the World Green Building Council has stated that all new buildings are to be net zero operational carbon with a 40% reduction in embodied carbon by 2030. In Toronto, as most of you know, a big portion of our construction in town is multi-unit residential buildings. And yet at the same time, it seems to be the sector that's been the slowest to sort of adapt and adopt, these processes. And so this team here, this multidisciplinary team, kind of sat down and kind of used that as a challenge to come together and try and innovate and figure out why is it so? What can we do right now? What are the tools and processes available to us? And we're going to hear from them as to sort of what they found together. Some brief introductions. Michelle Schwer is an architect. She's dedicated herself to the intersection of sustainability, research, and design realization. As VDP Quadrangle's Director of Innovation, Michelle provides the strategic direction required to embed innovation across the firm, as well as overseeing the firm's global innovation hub, a mechanism for crowdsourcing global ideation. Emily King, Emily King is an associate and with Intuitive and a leader in the sustainable performance team, with a deep passion for finding solutions in service of a sustainable future. With a specialized focus in carbon responsible, high performance buildings, Emily works collaboratively with service experts, design teams, and clients to guide the design of low carbon structural and building envelope systems. Brandon Law has provided energy consulting services to hundreds of mixed-use developments in Toronto, many of which have gone well beyond TPS minimums and even achieved net zero carbon levels performance. Brandon is the Strategic Director of Climate Change and Associate Principal at RWDI, helping developers and building owners improve, implement, and scale their decarbonization strategy. Bram Atlin is a principal at Smith & Anderson and leads their multi-unit residential team based out of Toronto. With over 12 years of experience with the firm, Bram has designed, managed, and collaborated on a wide variety of projects across the country and continues to grow his extensive technical experience. And last but not least, you have Julia Tennis here from Multiplex. Julia is the Vice President for Estimating and Pre-Construction here at Multiplex. She's a seasoned project costing specialist with over 32 years of experience leading to successful budgeting and cost control in large scale and complex projects across all sectors. And with that, I will hand it over to
Okay, great. Thanks for being here. So low carbon now. So Alistair told you this. This is the World Green Building Council's goals for where they want to get to by 2030 and 2050. So we all know net zero emissions. Always think it's important to say what it is. So it's a combination of the embodied carbon from the materials that we're using to construct our buildings, added together with the operational carbon of what it takes to run the building, and then subtracting your avoided emissions, so green power or carbon offsets. So what's happening in the market? As Alistair noted, we looked around and we thought there wasn't quite enough happening. So this is a stat from the end of 2021. This has actually since been updated, but I didn't update the slide because the work we did was based on this. So at the time, there were 323 cranes in the air and 288 were residential, so 90%. And as Alistair mentioned, it has really been the slowest to uptake on anything to do with climate change sustainability. Always been the most difficult to really make happen because it's done one development at a time, as opposed to sitting under the umbrella of a larger authority like the government. So we looked around to see, are we able to remove that thing from the top? So we looked around to see what was happening in the Toronto marketplace, and at the time, this was just before version 4 of the Toronto Green Standard came in. Thank you. There were only 5 projects that were going for the next level of the Toronto Green Standard, or tier 2, and we thought that was kind of interesting. That's not advancing.
Okay. You can only have one.
We can only have one, so.
You get to click on the slide.
Okay, it's working. Thank you. Okay, and then we looked around and we said, well, what about even higher levels of performance? Toronto Green Standard is pushing us towards these net zero buildings. Who's doing them? And we looked around and the only things we saw were things like residences and things like affordable housing. Those ones were going further. They weren't just doing tier 2 of the Toronto Green Standard. They were going to passive house or the zero carbon standard. So again, only a handful of those, and none of them realized at the time that we were doing this. And then we looked around to see what was happening in, what were other market indicators. So we looked at New York City, and New York City is really where the tall passive house buildings are happening. Again, on the affordable housing side, but it's where things are really starting to happen. So they're kicking it off, and with some of the legislation that's going on in New York City, we can expect to see this move fairly quickly over the next number of years. So green development standards. On the operational side, all municipalities have their standards. Some are better than others. Some really don't do much yet. But what we're starting to see is we're seeing standards that are going from here to here kind of overnight. So Ottawa put in a standard in which they had very little, and suddenly it's at the Toronto Green Standard level and beyond. And a similar thing's happening in Pickering right now. So the city of Toronto is the one that really kicked it off with the zero emission building framework, where they set absolute targets for energy use intensity, for greenhouse gas emissions, and for thermal energy demand. And this was a number of years ago. And they used the Toronto Green Standard to carry this out. That's the tool. And we're at version 4. So at the time we were doing this, we were subject to version 3, where there were 4 levels. We're now into version 4. The big idea originally was that by 2030 would be all net zero buildings. They've since changed that, so they're actually going to speed that up. So by 2028, all net zero buildings operationally. Kind of interesting because it's only 5 years and we're not doing very much right now, so we got to do this really fast. And so this group got together to think about what we can do. And we put this together to say that timing really matters. So projects that you're working on today, if you look at that the white circle in the middle of the gray, that's where you go in for your SPA application. And when you go in for your SPA, that's when you're tied into the level or the version of the Toronto Green Standard that you're going to be subject to. But you can see that the development timeline in advance of that can be up to 2 or 3 years long because of the whole rezoning process that we go through in the city of Toronto. So projects that you're working on now are going to be subject to these higher levels of performance. And what does that mean? And this sends off alarm bells for me. So embodied carbon is the other one. Up until recently, there were no standards in the city of Toronto. So there's this benchmarking study that was done with the Atmospheric Fund, City of Toronto, Mantle Developments, and University of Toronto. And they basically benchmarked a bunch of buildings on the residential side. They said, well, we think the target by 2024 should be around 500, based on the things that they did. And they put together this policy primer for the City of Toronto. And they said, okay, not just that, by 2026, we want to get to 415, 2028, 2030. So these are just numbers, right? Unless you're really into embodied carbon, which I imagine some people here are, you don't know what it means, right? So we benchmarked a bunch of our own buildings. So here's 8 of them. And in the light green, you see the embodied carbon, the upfront carbon of 8 buildings, where you include the area of the underground parking garage. The dark green is where you take it out. We've just gotten clarification that the way the city is going to do it is they're going to follow the CAGBC zero carbon. So you're supposed to remove the underground parking garage. So you can see those numbers. So there you've got your 2024, 26, 28, 2030. Some of those numbers are super high. You know, so getting those numbers down, that's going to be a challenge. So as of May 10th, so that's just not very long ago, there are now mandatory targets in the City of Toronto. For all City of Toronto buildings, they have to hit 350. That's mandatory, and voluntary is to get to 250, and that's effective immediately. Again, this legislation is changing quickly when it starts to change. Any project after May 10th that's going for a higher version, a higher tier of version 4 for the Toronto Green Standard also has a mandatory number to meet, and that's 350. And you can see those are business as usual buildings, so there's some effort that's going to have to take place. Again, it's happening kind of quickly. And they're talking about making it mandatory for all buildings by 2025. Again, pretty aggressive. So financial incentives, you get a development charge refund with the City of Toronto if you lock into one of these higher versions of Toronto Green Standard. You lock into those rates the day you apply for your site plan application. You pay those rates, your development charge rates, when you go in for permit. And then you get your refund back once you've demonstrated compliance with the Toronto Green Standard higher tier. And you get that money based on the rates that are current at that time, rather than the ones that you locked into. So, for example, a 200-unit building that has applied for TGS in 2018 would pay about $6 million in development charges. And by 2022, they get back close to $1 million back, which is pretty good. So there is some incentive available. So we brought this group together to have some conversations about how we can make this happen faster. Again, because we can see that projects we're working on now are going to have to get there. How do you do that? So we put out this initiative called Low Carbon Now. You can go to the website later if you want. We're going to give you a snapshot. So this is just to say that the decisions we're making today are impacting the carbon trajectory of our buildings for the lifetime of those buildings. We're basically locking these buildings in to this pattern. What you see in orange right there is the embodied carbon. So in the light orange, that's sort of business as usual. And then the darker color is if you think a little harder about it and do some work on it. What you see at the bottom, the 85% and the 40%, usually you think about embodied carbon over the life cycle of a building, so a 60-year life cycle. So you say, oh, well, it's about 40% of the carbon emissions for the building. The 85% is between now and 2030. And that matters because we're trying to get our emissions down now. So if you think about it, your embodied carbon emissions are emitted the first day, right? As the building's being built, before it's even open, which is why embodied carbon is becoming increasingly significant. So we said, let's come up with 3 things that we need to do. And we said, build smarter structures, prioritize the enclosure, and electrify the heating systems. So with that, thank you.
All right, so starting with embodied carbon, we focused on the building structure first. So what are some key things that we need to do to try to reduce embodied carbon in the structure? And firstly, prioritizing reducing quantities. Before even talking about any low carbon materials, let's talk about reducing material quantities, because that's going to have a really big impact on reducing overall embodied carbon. So we started with this 40-story multi-unit residential building kind of archetype with 6 levels of podium. We assumed that there'd be 4 levels of below grade parking, kind of keeping consistent with standard practice. Assumed a transfer slab, 1 transfer slab at level 2, which is a monolithic slab of 1,800 mil thick. We assumed kind of standard practice again in Toronto is to have shear walls between your suites and some columns that are also working as a vertical structure. We had 200 millimeter slabs throughout and used just a conventional concrete mix design in the baseline condition and assumed cantilever balconies. So we wanted to see what kind of design decisions do we need to make to look at ways to reduce our volume of concrete in all these different areas. So starting first with the slab thickness, slabs typically, especially in a high-rise building, are going to make up the vast majority of your overall volume of concrete. There's just many repeated slabs. It's a huge volume of concrete. So anything that you can do to reduce your thickness of your slabs is going to have a big impact. Now, there's lots of knock-on effects to doing that, but kind of looking at this from like a high level, more simplistic perspective, we looked at a few different construction techniques that could be used to help reduce that thickness. So we're starting at 200 mils, which is already pretty thin, but how can we get thinner? So we went down to 180 mils as what we thought was, an achievable slab thickness using a backshoring method, which is typically practiced more in other parts of Canada. And then we got down to thinnest at 165 mil with a post-tension slab approach. That's not typically practiced that much in this region, but that's still a pretty significant reduction in your overall slab thickness. But we decided ultimately for this study that we would stick with a more practical approach, which for the way that construction is being done today, sticking with that 200 mil slab, but still interesting to see that we could achieve some pretty significant reductions by reducing the slab thickness. So next we looked at the lateral system. So like I said, traditionally we typically have shear walls between all of our suites. That's acting as lateral and vertical, but we wanted to see what if we just went with discrete columns and had a thin wall and a central core acting for our lateral. And this is something that is done a bit more in other parts of the country. So we were able to see that we could achieve a 6.2% reduction in embodied carbon overall going with the discrete columns, and that's after accounting for adding back in the embodied carbon of your demising walls that you still have to have between the suites. So still seeing a pretty significant reduction by changing that lateral system approach. And then also looking at our below grade structure. So I'd say between this and slabs, they're both pretty big contributors overall to embodied carbon. So in this case, the below grade structure made up around 28% of the overall embodied carbon of the structure. So that's pretty significant. Anything we can do there to make reductions is going to have a big impact. And that kind of rings true with a whole bunch of other studies that have been done, looking at kind of the amount of carbon and concrete that is below grade, kind of this iceberg effect. There's tons of embodied carbon that's happening below grade. And so we need to be smarter about how we're using that space. So in the baseline condition, we had 4 levels of below grade parking. And in Toronto, if you're below the water table, you have to tank your foundation. So that basically means you're putting in a lot more concrete. So anything that we can do to bring those levels up and ideally get above the water table is going to help to significantly reduce that volume of concrete. So for our low carbon design, we decided to go with saying that there would be 1 level of below grade parking, and that achieved a 12% reduction in embodied carbon, which again, pretty significant, especially once you add all these things together. So those were all design decisions that were made to basically just try to reduce our material quantities. And we ended up with this low carbon pathway. We split it into ideal and practical. Ideal from a slab perspective, if we could get down to that 165 mil slab, that would be ideal. But again, for this study, for the low carbon pathway, we stuck with the practical pathway, which we assumed is going to be a 200 mil slab. But we assumed no balconies. We had those discrete columns instead of having shear walls between suites. And for transfers, we ended up, instead of having just a monolithic 1800 mil transfer slab, we instead were very deliberate about where we were going to be transferring out elements and use things like transfer beams or wall beams. So again, just reducing the volume of concrete. 1 level of below grade parking. And then after all of that, we were able to see in the ideal pathway, we could probably achieve a 35% reduction in embodied carbon. That's before even touching the type of material you're using. And then in the practical pathway, more realistically, probably a 28% reduction. So now let's look at some low carbon materials. So we wanted to look at different types of concrete, using Portland limestone cement, using increased percentages of supplementary cementitious materials like slag, looking at using lower carbon rebar, and then also playing around with Lafarge's EcoPact concrete, which is kind of an off-the-shelf low carbon concrete product, which can achieve pretty significant embodied carbon reductions. And so ultimately, we said, okay, what if we went with an eco-pack product and low carbon rebar? Well, we could see an additional 34% reduction in embodied carbon. So overall, for the structure in this building, the design strategies alone, the practical pathway, we could see a 28% reduction, an additional 14 to 34% reduction if we look at lower carbon materials. And overall, I think it was a 52% reduction from baseline with going with that practical pathway. So that's something that's like achievable today. Like this is something that's practical. We could be doing it now. But then we also want to see how does this rank. So there is a ranking system. iStruct-E developed their scores rating system for structures. So looking at, what should we be targeting for embodied carbon in structures. And so this building, the low carbon practical design would rank around a B rating. And so you can see in this graph, basically the shaded area is representing our global carbon budget for structures globally between now and 2050. So this building today would fall well within that budget, but in less than 10 years' time, it's going to fall outside of that budget. Just emphasizing that there's going to be more work for us to do continuously year over year to continue to reduce our embodied carbon emissions in our structures. And really this whole study required us to have really close collaboration, the architect team with the contractor to see what's feasible, what are going to be some of the knock-on effects of some of these design changes that we're talking about. So that was a nice takeaway of realizing, we all really need to be at the table very early on talking together rather than individually working in a silo. And so some of the big structural takeaways, engage your structural engineer as early as possible. That's going to have a big impact. Some of the design decisions that might be made architecturally might be kind of locking you into higher embodied carbon solutions. So bring your engineer on board, bring your embodied carbon specialist on board early to help make sure that you're coming up with a low carbon design. Simplifying the structure as much as possible, trying to eliminate any kind of crazy gymnastic stuff that's happening that might be resulting in having a higher quantity of materials. And that kind of ties into minimizing or eliminating your structural transfers. So eliminating some of that structural gymnastics that might have to happen, trying to have your vertical structure go top to bottom with minimal transfers. Like we had talked about, minimizing your underground structure. So that's where a lot of concrete lives, a lot of embodied carbon. If we can avoid tanking by having it be above the water table, that's going to be ideal. Looking at having these discrete columns or wallums instead of having shear walls between all the suites, also a good way to reduce embodied carbon. Ooh. And then specifying low carbon materials as it makes sense. So investigating what sorts of different materials could make most sense for your building. Hybrid options work too, but for MRFs, we're typically seeing a lot of concrete. So looking at some lower carbon options there.
Thank you. All right, so operational carbon. All right, so the TGS gives us numbers that we're trying to target for. Stop it again. I don't know what you did before to fix it.
I just clicked.
Okay, all right. Let me go back. Okay, so they give you a bunch of numbers. They give you the energy use intensity, they give you the TEDI, which is the thermal energy demand, and they give you the greenhouse gas intensity. And so, what do those even mean? So you've got your EUI of 70, and really to get down to that number, the main thing is you have to reduce your energy demand. Then you've got your TEDI of 15. So if you'll realize that's actually quite low. So this is two things that are dependent on this, and that's optimizing your enclosure, so really lowering that window to wall ratio, simplifying the, creating a compact form, so really simplifying the form, simplifying your windows, so less mullions, higher quality windows, ideally triple glazed windows to get to here, and then a proper cladding system with a high effective R value. Combine that with your balcony strategy, minimize those balconies, eliminate them, thermally break them, do something about them. And then the other half of it is the ventilation strategy, and this is where it can get confusing, these two things tied together, unless you're a mechanical engineer. And so the ventilation strategy is the other part of that, and these guys are going to tell you more about that. And then the GHG of 5, so getting that. This is all about fuel switching. This is getting away from fossil fuels and electrifying buildings. So how do these connect together? Number one is the TEDI, so everything doing the envelope first. And then the better the envelope, the less demand you have. So the lower your EUI, the less expensive it is to heat and cool your building with electricity. So it's all tied together. So our next big one was prioritizing the enclosure. So we have a couple of samples. We did a study for a client outside of Low Carbon Now, where we worked with Synergy and Purpose and I think it was DCL that did the pricing for it. And we did this very early on in the design, which worked actually very, very well. Looked at a whole bunch of different systems, super insulated buildings, triple glazed windows. We looked at a whole bunch of large format 2D panels that had the windows already installed, precast. Whole bunch of companies are putting things together right now. We've been looking at these glide-on balconies. I think we might be speccing these on a project now. But the point with these is that they are only thermally, you only have thermal bridging happening at these points rather than along the whole linear. The other thing that we've been looking at, so we tested this actually with a lot of people that are on the panel here. We did air infiltration testing. So we did this on 80 Atlantic recently, where we targeted a certain level and did blower door testing. We came in below what the target was, but you can see it's still not close to passive house standards. That wasn't the goal at the time. But what we did get out of it was a higher quality building envelope, and we were able to use the air infiltration as a way of indicating that or energy savings. So as part of this, there was this mega Excel sheet that looked at all these systems together and how do you make a decision about this. And so looking at it up close, you look at the system, information about the assembly itself, its performance, its aesthetic, its cost, its schedule, its constructability. And what we thought was missing was also the carbon. Because when you're thinking about envelope systems, you're really just thinking about the operational carbon, but it also has a really big impact on embodied carbon. In fact, about 25% of the embodied carbon in the building comes from the envelope. So we did our own study of all this high performance envelope systems that the envelope consultant was looking at. We took those and did a study about the embodied carbon of each of those systems and sort of shared that back with the team, just for knowledge. And we turned that into this funny little chart. So on the left-hand side, you've got the orange, and the orange is the RSI, or the effective thermal value of the walls. And you can see, other than the large format precast or prefab panels, they were all about the same. They're all in about the same range. On the right-hand side, you've got the embodied carbon. You can see that they perform very, very differently. So where the high performance curtain wall, people might have wanted to do that because, you know, it looks great and, you know, you're getting pretty good effective R value. You can see that the embodied carbon is really abysmal on that. And so we came up with this little ratio of global warming potential to RSI, and you want to keep that number down. Then we then looked at a whole bunch of different cladding systems to see, and you can see that aluminum is really the worst offender, and that's what we build most of our residential out of. So there are all kinds of studies that have been coming online over the past year or two. So much information out there, so just putting that out there in case this gets shared, so you just have that reference material with you. So reductions for, that went really fast, for embodied carbon on envelope. Understand the carbon properties of the materials you select, use aluminum judiciously, maximize your stud spacing, and specify low carbon insulation, and consider that ratio of the global warming potential to the RSI. And the lower that number is, the better.
So I'm here to bridge the gap between passive systems or envelope systems predominantly, and the active systems that Bram's going to talk about in just a few minutes. This is the approach that we take and encourage every project to take, whether it's new construction or retrofit of an existing building. To start with your passive systems, then you look at your active systems. To the extent possible, to the extent that economics allow, that project constraints allow, optimize your massing and orientation from an energy and carbon standpoint before you move to optimizing your envelope systems, reducing your window-wall ratio, before you start selecting and optimizing your opaque envelope performance and your glazing performance. Then when you've done all of that, you can start looking at reducing your internal gains, you know, high efficacy lighting, Energy Star equipment, things like that. And improving your occupant behavior. Only then do you then start reducing or addressing those remaining loads, which are now hopefully much smaller than they would have been otherwise, through active strategies, through HVAC. We take this approach for several different reasons, so I'm going to talk about a few of them now. One of the biggest things is the longevity of the impact of these. And I'll just do that through an example here. So this is a real project that we worked on, new construction on the left-hand side there. It wasn't that color scheme, but still an idea. Just through massing orientation and envelope scenarios that we ran, those passive upgrades resulted in over 600 tons of CO2 saved per year across that development. And the thing that's really important to think about here, when you're, especially when massing and orientation, window to wall ratio, things like that, you're making decisions that are going to be locked into that building, that neighborhood for, at least 50, 60 years, probably much more than that. So it's really important to get those decisions right and to prioritize those decisions, to think about that temporal scale when you're making these decisions. Whereas a lot of that mechanical equipment has a 15, 25-year lifespan. So you can swap it out. You're not missing that much if you really need to hit a decarbonization target. And just if you start looking at that years, you start multiplying, this is just carbon tax implications up here at 170 per ton at 2030 across Canada. At least $100,000 a year just associated with carbon tax that would be saved just from those massing orientation and envelope changes in the building. So $3 million cumulative over 30 years, 5 million after 50, 10 million after 100 years that the residents of those buildings would have to pay, obviously. And again, that's not even including the utility costs that were also saved. Another thing is passive survivability. So you can test this. You can build a model of a building with certain envelope performance characteristics and simulate something like a power outage and see what the impact is. So we took an extremely cold Toronto winter week, I think one of the coldest ones still, February 2015, simulated a power outage, which you can see is that black line going right down the middle. What you have is the blue line, the indoor air temperature of a typical design. So this was a minimally OBC compliant building through the performance path. So not a prescriptive R20 envelope. It was like an R4 spandrel for a multi-unit residential building. So really low performance. Anyone who tells you that the Ontario Building Code is sufficient for energy performance is not correct. And then you have the proposed design here. So this was actually the passive house standard. So an R4 spandrel versus something that was closer to an R30 effective opaque envelope. And you can see the huge difference in indoor air temperature from those two scenarios. After just a couple of hours, the indoor air temperature drops down to 6C in that OBC compliant building. You're good for almost a week with some people in those residents in the passive house building. Also because you have some solar gains. Why would you need weeks? Texas is a good example of, hopefully a worst case scenario. That was a 2-week duration. Hundreds of people died from that scenario of a 2-week power outage duration. And then we're going to start getting into the active systems. We are very fortunate, especially in Ontario, to currently have a grid that is quite clean, extraordinarily clean, 93% renewables currently. We need to take advantage of that in terms of decarbonizing our buildings. It's going to be a key linchpin to all of our decarbonization strategies in buildings. For those of you, this is just I think Michelle kind of gave a little bit of introduction to this in greenhouse gas intensities and calculating those. But to get greenhouse gas intensity, you take your electricity consumption, you take whatever other fuel you're using, predominantly natural gas, you multiply those by their emission intensity factors. In Ontario, as I mentioned, we are far cleaner electricity than natural gas, at about a 5x benefit. Here's a way to visualize that. If you're just looking at a one-to-one comparison, so let's say assume 100% efficient natural gas boiler, that doesn't actually exist, but just let's pretend, and 100% efficient electric heater, which does exist. This is and you multiply that by the emission factors, this is the relative impact here. So you can see the very clean provinces being Ontario, BC, a lot of the Alberta, Saskatchewan, Nova Scotia being quite dirty because they still have some coal and a lot of natural gas in their generation. But that's not really a fair comparison. As I mentioned, a 100% efficient natural gas boiler doesn't exist. You might get 92, 93%. With even just an air source heat pump, you can get a seasonal COP of 2.5, so that's a 250% efficient. So you need to take those efficiency corrections into consideration as well when you're making a decision on when to electrify. And so if you correct that, you go from these dots on the left to now natural gas, you know, being a much bigger, dirtier source in the vast majority of provinces across Canada. Here's another way to look at this. This blue line got messed up, and you can see the blue arrows here. So every province with a green dot below these blue arrows, it makes sense to electrify just with a air source heat pump. If you want geothermal, you could get even higher COPs, and that line would even go farther. So important to consider. Electrification makes a lot more sense. You can't just look at it a one-to-one comparison. You have to correct for efficiencies as well when you're looking at emission factors. And here's just a zoom in on the cleanest provinces that we have in Canada, and how many of those dots you can fit into one of those natural gas. I think Quebec, it's something like 300 or 400 dots, 300 times more efficient when you start taking into account electrification strategies. So as I mentioned, this is all building on this assumption that we have this clean grid and that it's going to remain clean and that it's going to stay clean, or improve hopefully over time. We have this huge challenge here that we've realized in the building industry that we need to electrify our buildings. We are going to be putting a lot more buildings, switching them over from natural gas to electricity. A lot of other industries are doing the exact same thing. Whenever they can electrify, they see that as a key ingredient to decarbonization. The problem is everyone's putting stuff onto the grid. Forecast electricity demand across Canada is anticipated to increase 47% by mid-century. And half of that increase is driven just by building electrification. So this is huge. We have to invest in our passive systems, reduce our loads as much as possible, especially in a new construction context, to ensure that we are not putting additional burden onto the grid. That's going to have a lot of difficulty keeping up. In Ontario specifically, a lot of our nuclear plants are scheduled to be decommissioned in the next 5 years. The proposal now is to put a lot of that on natural gas, unfortunately. So we may see a decrease in our renewable portion, and an increase in our emission factors for electricity in Ontario, at least in the short term. The other thing, because we're going to be putting more and more demand on the grid is anticipated to be strained for quite a while. I anticipate, and this is based on really nothing other than my own, it just seems to make logical sense. The shift to encouraging people to pay, or requiring people to pay based on their peak consumption. So a global adjustment Class A structure currently in place for a lot of the big consumers that you see just out this window, where they pay all of their annual utilities based on the peak demand, peak 5 hours for the grid in the year. So you can see those 5 little blue dots. This building was paying based on their percentage of contribution to the grid demand at that time. The folks that invest really heavily in their passive systems are going to be way better prepared to turn down thermostats in anticipation of this, to not see those dramatic swings and peaks like all of their peers, and would much better able to take advantage of these types of road structures moving forward. So again, passive systems are absolutely critical, especially in the context of electrification. And then the last thing is, I think one of the biggest problems with investment in passive system is that the return on investment is often very low. But I think that's okay, because we should be thinking of it as more of it's like the savings bond. It's extremely predictable what you're going to get by spending $1 in a passive system upgrade. You're not subject to increases in electricity and natural gas, except that it's probably going to get more and more expensive. You're not picking a fuel over another. You're constantly going to see savings compared to the alternative scenario that you also looked at. And then the last thing is geothermal is one of the best electrification strategies that we have from an efficiency standpoint, where it is achievable. You for these really, dense urban developments, we need to ensure that it's a valid solution. You can only drill too deep before it becomes technically and economically very difficult. And you want to be able to address the full load space heating, domestic hot water and cooling load with those geothermal developments. What you need to do to allow that to happen, especially for dense urban developments, is to ensure that you've invested in your passive systems.
Okay, so I'll give a bit of information on the active systems. That was a great primer. So some of the technologies that we're using in buildings today to electrify them mostly, and then how we're doing some of the other systems that we're not yet electrifying, but we will be electrifying very soon. As you've heard today, a lot of the discussion's been about reducing before we reuse and recycle. So I'm the guy that reuses and recycle. The passive systems are the reducing piece. And it's really important to get that right, because we can't electrify. We can't serve these buildings with some of these technologies if the absolute load is big. So that becomes pretty important. So as we move towards electrification, even if you're not going to be zero carbon today, we should certainly be thinking about how we're zero carbon in the future. As Brandon pointed out, some of the decisions you make on envelope and structure, that's going to be there for the life of the building. Mechanical might be there for 16, 17 years. Some of the things you're doing will sort of set yourself up for failure, success in the future, but there are pieces that can be retrofitted and replaced. So even if you're not going to be zero carbon today, we should be asking, how are you ready for tomorrow? So that could be, supplying some things that we've been doing for a long time, putting in systems that can handle low temperature water, so you can convert it later to even lower temperature water, be geothermal ready, extended range heat pumps, even if you don't need extended range today. We're seeing that on a building right now that's being converted to geothermal. So about 5 years ago, when they started replacing chassis, they made the decisions to spend $50 more a chassis and make it geothermal ready. And they're seeing that benefit today. Think about your electrical service. We'll talk a little bit about electrical, but it's funny that the electrical component, the electrical distribution systems is often an afterthought in electrification. I know that sounds weird, but mechanical engineers will come and talk to you about electrification for hours, and you don't get a lot of good information on the electrical system. So we've done some good studies on that, and there's a bit in here as well. Energy storage, geothermal being effectively one of them. Depending on your view on geothermal, it's an energy storage. And there's many other forms of energy storage. We were talking about batteries, that could be energy storage. There's all different types of energy storage. And I think storage in itself and all forms that it takes will be a huge part of this. And then hybrid systems. In the spirit of simplicity, a lot of buildings avoided hybrid systems, but building in these environments isn't as simple anymore. So when you talk about, big and tall being tough to do geothermal, which is absolutely true, we're seeing a lot of good case studies where really big and tall, which we see all over here, are effectively two different mechanical systems for other technical reasons. They have pressure breaks. So it's kind of natural to say, well, why don't I do geothermal for this part of the building, and then I'll do heat pumps for this part of the building. Those two parts never wanted to talk to each other anyways. We always put in these heat exchangers and pumps, but they're effectively two different buildings. So it's not a complicated hybrid system to do that, because it's already sort of two different buildings for other technical reasons. I have a few slides here to kind of show you, to demonstrate a few different things, but we're going to start with the old approach, the conventional approach, which is a lot of natural gas heating for domestic and HVAC. And then the other things, cooling was mostly electrical through chillers or heat pump compressor usage, and some of the other bits and pieces you see in the building. And part of showing you this side by side is, one, to show you that even in a conventional building like the one we studied as part of the study, you don't really need a lot more space. It doesn't get that much more complicated just at the 10,000 foot view, which is what I'm showing you here. So when you compare sort of this old approach, which has a boiler plant, natural gas boiler plant, And in this particular case, chilled water system. So we have a chiller and cooling tower and then domestic. You look at some of the other contenders to get, zero carbon or near zero carbon or significantly reduced on the carbon side. You look at, the main competitors is some form of air source heat pumps. And I would just say I would lump a lot of different technologies. If I'm looking at this again from a 10,000 foot view, VRF would kind of be in your air source heat pump range. It's similar technology. So air source heat pumps would be a very natural fit to decarbonize a building, and you're not going that far, left of center to do that. And then geothermal was discussed, and within geothermal, not really quite exactly geothermal, but I also have district energy here, and we're seeing a big push on district energy. And district energy can be, central plant for a small number of buildings on one property. We're seeing it in micro communities, and then on a very large scale, district energy that's running through our municipal streets. And district energy is very interesting on a number of different levels, similar, in the similar vein of how our utility is green, and maybe it's becoming less green, hopefully not, but it looks like it's trending that way. If it becomes more green, at a central level, you can start to move the needle on carbon. So district energy has the ability to do the same. So we're seeing some really interesting, viable projects, even for the private developer in the city that needs to contend with, what's happening, cost of construction and price point. They can do a district plant that serves 7 buildings. And the first phase, plug years could be conventional gas, but then they can start to do a lot of geothermal and a lot of electrification on phase 2, 3, and 4. And the blended average of what's coming out of that plant looks pretty good by building 6 or 7. And they actually time that so that as they phase that plant, it meets the pro forma of each building, because the future building has to meet TGS version 4, and then the building after that has to meet TGS version 5. So when you look at it in that context, that's what they would have had to do anyway. So that was a really interesting study, and one of those that we're doing is being implemented, which is pretty exciting. In the grand scheme of how we electrify, which will probably be a lot of geothermal, a lot of heat pumps, those are the 2 big contenders. We do find that with this bar right here, natural gas is the hardest to electrify, and there's a whole bunch of technical reasons, but it is the toughest to electrify. It has a really punitive peak. We're talking about peaking, right? So you set up this big system so that you can take, that one peak when everyone gets up tomorrow and showers and goes to work, right? And the temperatures you're dealing with and the flows you're dealing with make it really tough to electrify. But there's a lot of ways, thermal storage, and maybe small peaking plants. So if we do all the other things, if we make good choices structurally, envelope, and all these different ways, you have a little bit of a carbon budget to maybe do some of these things, even in natural gas, which may make sense as long as they're very small and selective. And you can only do that if you make all these decisions to use your natural gas budget in the right way. Michelle talked a bit about TEDI, which I would agree, ventilation is probably the most confusing piece about TEDI to most people. TEDI is easily thought of as, your envelope, right? How well does your envelope perform, which basically dictates the heating or cooling demands in a building. Ventilation is tacked on there. I believe in recognition that ventilation is needed in a building to be a healthy and safe environment. So you can't just ignore it, right? So you need ventilation, and that ventilation, when you consider our temperatures outside, takes quite a bit of energy to heat and cool. I didn't get a chance to update this slide based on a conversation this panel was having yesterday, but anyone who's really familiar with mixed use residential buildings, you hear mechanical engineers all the time talk about CFM per door, right? You start a building and people like Brandon are saying, how low can you get that CFM per door, right? And we say, I don't know, 50. And he says, you're crazy. Okay, 30, you start negotiating from there. So some typical values you hear are 30. I think now we're 30, most people are comfortable with 20, getting down to 15, somewhere in that range. Code minimum, like the absolute minimum, if everything was ideal, you could get down to 5 CFM per door, maybe 4 CFM per door. It's actually not a CFM per door. It's a very small amount of air per square foot that your corridor needs per ASHRAE 62 to be ventilated. So it might be 200 CFM total for that floor. The reason us conservative engineers don't let you get down there, is there's other operational and practical issues that are really challenging. So stack effect as we build tall, right, and skinny in this climate. As we, you know, look at appliance selections, you know, people want to live in condos or need to live in condos and they have the full size appliances that exhaust a lot of air. There's also practical concerns. You don't want to smell what your neighbor's cooking for dinner and all these different things, right? So, but if you get into a really ideal scenario, you can get that way down. So that's somewhere where we need to be. I don't know which button you were pressing here. There we go. So now on the electrical systems, which I said doesn't get enough attention, you really need to consider, you need to plan for that in advance. You know, geothermal, heat pumps, electric boilers, like these are all the things you're going to talk about and see on buildings, and they all have varying impacts on the electrical service. But one thing's for sure is they all increase the electrical demand on the building versus the status quo in Ontario being natural gas. So we really need to start to plan for that in advance. You need to talk to utilities in advance, and you need to talk about the things you can control. So when you guys, you didn't really mention it, but one of the points on your slides is EV charging. Well, you know, load management just has to be a part of it, right? You can't have these things that just can all peak at the same time and expect to have enough of a budget, enough electrical capacity for the other things you want to do. We did a study, which we've done this in a few different variations, but one stuck with me because I think it was one of the first ones I did in depth. And we looked at different ways to electrify a 60-story tower in this neighborhood, actually. And what we found wasn't that surprising. Electrical boilers, you know, gas-fired heating, these values may not mean much, but they're relatively matter. So, you know, an gas-fired heating system required 800 kilowatt incoming service. As you'd expect, an electrical boiler is effectively not feasible. And it came in at the lowest capital cost. Like electrical boilers are cheap, but you know, it also required a $10 million infrastructure upgrade from Toronto Hydro above what they budgeted, what would be normal for that building. And that was just, I think, a dart on the wall by Toronto Hydro. I don't think they actually looked at it. They said, "You're crazy, go away." You know, and we did a bunch of different options. Air source heat pumps, which you'll see a lot of them on proposed on these type of buildings. It actually came out pretty demanding on the electrical side, but I think we need to get our minds around that and plan for that. And then if you have geothermal, this one says partial geothermal because it was actually too tall and slender to do all geothermal. To do partial geothermal, you know, really you can see it was compatible. It was comparable to a conventional system. I think I had one more slide here. There we go. And the last thought I'll leave you on, and you know, one of the conclusions we came out of this kind of got us thinking about not only how do we do a low carbon building now, but what's the next step? You know, I got my juices flowing. What am I going to be presenting to this group in 10 years from now? And part of that, you know, I think we'll be talking a lot about refrigerants. We already are, but in a different context. We'll be talking about refrigerants in terms of a carbon budget. We're already seeing that in Vancouver in the STEP code. So they're allowing a certain amount of, you know, and it's really operational carbon based. So the way it works is they factor in refrigerant leakage rate, and that has a global warming potential and a carbon potential, and that gets tacked off. So things like VRF, which has kilometers of piping, won't fare as well as a central, you know, air source heat pump, for example, because the amount of volume, the volume of refrigerant will have a higher leakage rate. And so it's not quite capturing the embodied carbon that is actually pretty impactful. The first charge, that first bit of refrigeration is a huge part of that story, but it's captured indirectly by looking at operational by leakage rate. More volume of refrigerant has a higher leakage rate. So if you have to reduce that, you're also reducing the first charge. So those things are aligned. And one of the points I was going to make is that if we're seeing it in Vancouver now, we're going to see it in Toronto very quickly. That's happened with a few other things. So I think that's coming quicker than we think. Just like the embodied carbon piece got tacked on to Toronto Green Standard, I expect this to get tacked on pretty quickly. And then, you know, we started thinking refrigerants is kind of an obvious one because we've been talking about different refrigerants for a while. That's a different spin on it. But I think we'll be talking about embodied carbon of M&E systems as well. I mean, it's the next fit. Once structural gets their act together, right? And that's just the given. Every building's just low carbon without thinking, and envelopes the same thing and all that. You know, they'll just turn their sites to us. And there are things out there. One thing I found is that there's very little information. Am I way over time now? I don't know. Okay. There's very little information. We did one study as best we could on a chiller life cycle. And as you expect, operational carbon was the biggest piece, which is already being addressed based on everything we talked about. Refrigerants, the next piece, and then transport and all that. So there's not a lot of good information, but you know, we did find that there's some people out there thinking about it. And I just saw a good example here, which I'll show you. If you look at any one of these round backs and you see that wire that's holding it up, conventionally, it might be a strap, right? It might be a piece of metal that's strapped to it. Well, and then there's a company called Ripple. I don't know if that's exactly Ripple. And it's like 90% less material. And one of the things they're starting to promote, I went to their website before this, and they say we're 70% less carbon than the next person. So you're already starting to see some people that have no metrics to go by. They're not selling you a lead point, right? You know, put in a bike rack and I'll give you a lead point, but they're already starting, they know that that's going to come up. So there are things like that that will start to rear their head, which will be nice.
So we heard a lot about what we can do to lower the embodied carbon, like on the construction, like on the structural side, with like the best like structure to use. What is the type of a slab, like thickness of a slab, what we can achieve the most savings in the carbon, like a carbon footprint. We talked about envelope and like what's the pre-panelized system with coming in with the thermal grain standards and the new environment that we need to achieve. But can that all be sustainable from a buyer's perspective, from a cost perspective? We know that the government in Canada is like doing like 500,000 immigrants a year coming in Canada. Most of them are going to end up in Toronto. We know that 189 cranes are only on residential side. So business is on, like, you know, cooperation side is booming. There's a lot of buildings being built, and those new immigrants they will need to live somewhere. So there will be more new buildings that need to be built on a cost that's like affordable, and also on a schedule that they can like enclose all of them. And going backwards.
Yeah.
Here you go. So I'm not going to take credit of all the work that was done before. There was like a couple of individuals from my team that worked alongside with the panel of the experts here. They took upon a building that's a test project, and what we typically see here in Toronto, it is like, you know, 400 units, typical project, 4 levels below grade, 40 floors above, elevator with a seasonal lift stairs, with like, you know, floor plate of probably about 700 like, you know, square meters for all together, number of parking spaces. The general assumptions, like what we usually typically see in every single typical residential buildings here in Toronto. The test project that we priced was like, you know, top hat aluminum panels, the typical window wall type of application, what most of the developers know and most of the general contractors know, because it's the cheapest way to build, but not the most sustainable way of building a building and getting like the carbon footprint out of it. I know that we discussed like, you know, pricing up 4 levels, instead of giving 4 parking levels below grade, to drop it down to 1 so we can eliminate the bathtubing and eliminate the carbon footprint below grade. Using that, the buildings is going to get built faster, just because of like, you know, the total, the concept of a building. If that building was 44 stories with 4 levels below, it's about $400 million. The 29% of the cost of the building is in concrete. So solving the structure itself and like the carbon in the use in the structure is one of the elements that we need to do it right now. Out of those 29%, 16% are below grade. So most of the savings we're gonna get if you have like buildings there, like have like one level below, or maybe readapt on parking usage, maybe like share like, share bike rides. The next element is doors and windows, 9% of it. But the cost between the concrete, the cladding, and mechanical electrical systems comprise of a 75% of the cost of the whole building. So solving those 4 elements, which is like, we make sure that we lower the embodied carbon, but we don't exceed the cost of the market can sustain. Typical baseline of the cost of certain elements for the building, all like benchmarked by the total constructible area and total price per GFA and a percentage of the cost. As I mentioned, 9% of the cladding is like within the doors and windows. Selecting when are we going to go with a window wall system or a curtain wall or pre-panelized system. We did a study of 2 buildings that having like one of the building will have the window wall pre-panelized window wall system on the cladding. The next building next to it had the curtain wall plus the unitized pre-panelized metal panel system. None of the cladding elements were on the critical path. The critical path was going through the structure itself and the mechanical systems and making the mechanical penthouse unit. So making the selection of the pre-panelized metal system on the outside or pre-panelized cladding system on the outside, that's not going to take the time of using the crane to install it. It's where like, we're going to get savings on the duration of the schedule. I know we talked about using eco-packed concrete or any kind of sustainable concrete that has like low carbon footprint. It comes with a price tag and also comes with duration of the schedule because none of those eco-pack or like a low carbon types of concrete have a curing time frame that's going to fit the current schedules that we have or the duration of like a project construction. The more additives you put on it to build the buildings faster, the more we gain going away from having like lowering down the carbon footprint. So we need to have the right balance of where we're going to use it and what we're going to use it for. The assumptions will having a less floor below is probably better suited, and you still can have like the eco-pack or type of like a low carbon footprint concrete above it. It will not reduce the duration of the project and not going to affect the cost of the building itself that much. Using we did a study of using a pre-panelized metal wall system, and that will be the study we did was on the Flynn flat fast wall. The cost increase for using that panel like that type of a system, 7.83% of the cost of the project, opposed to using a unitized curtain wall system 404. So we need to wage our battles. What do we want to do on the cladding? Cost-wise, or like lowering the carbon footprint, or talking about the using the appropriate mechanical systems to go with it. A little bit of like cons and pros for the envelope prefabricated panels. There are quite a few of them right now. There's a lot of type of pre-panel system from talking about Flynn's fast wall, the ceramic tax pre-panel system that comes with enclosing the envelope and putting like less air leakage on the exterior of the cladding. We actually had a cladding system, glass that's going to be used as a solar gaining component, like a matrix glass that can be used as a solar panel on the envelope of the building. We haven't got to a project here in Toronto, like on residential side, and how much that's going to cost, because the cost of that system is quite high, but it has a lot of potential of harvesting the energy from the outside, and in addition to the geothermal energy. We did the research of like having residential balconies, like building with no balconies, based on the task project that we had. The cost is actually 1.39% down, not up, like that's but we gained 6 weeks on the schedule, and we lower the carbon for like 3.21%. using a glide on steel balconies, the cost goes up, but we save on a schedule and we save on carbon. So whatever we want to make, we need to make a choice early enough in the stage, what type of a project, type of an element we pick, and what the cost effect of the edit element that we pick. I want to talk about a little bit like, what we do as in Multiplex as construction managers to help the developers and the rest of the team to make educated decisions early enough. We partnered with EC3 and also purchased estimating software called CostX that essentially captures the 3D model information and the quantity of it, but also through EC3 uses the EC3 model with project EPDs to give you the carbon footprint, and you can trail it through every single stage of a project. Every time, even in early stage when you have this schematic set of drawings, you can put a tag on the carbon footprint and how much we can save within that project if we use different type of a concrete or different type of a cladding. Every single time there is a new update, we can always trace it how well we do within the parameters. Talking to one of the examples that we have on project on Delisle, we did a heat map on the concrete and making sure we kind of challenge the consultants of the type of a concrete they use, how well they use it. Everything that's like in the darker purple, it's the more condensed, like high concrete strength ratio. Is it really necessary to be like concrete makes 70 MPa, or it should be like a little bit less? It's all about give and take. With lowering down the cost, you're lowering the carbon footprint. Just some of the concrete mixes that we use for assumptions. Currently, it's only Inocon that's giving us like EcoPact, and actually on every single new project, they don't even quote any standard types of concrete. You can actually use only the EcoPact type of concrete. There's a lot to be done and there's a lot of work to be done. Actually, I was really glad to see that everyone wants to sit down on a table and discuss it. The decisions need to be made collectively in early stage of a project. There will be no one size fit all the projects. Depending on what size of a project that you have, you can pick and choose between like everything that was discussed today. But every decision that needs to be made like how much of that can be actually the purchasers can sustain on a cost side. That's what I have for costing.
Thank you. Okay, we're almost done. Last few things. So takeaways. We're used to thinking about time, quality, and cost, and they would always say just pick two because you can't do all of them. Now we're going to actually ask you to pick four because you actually have to throw carbon into the mix of all your decision making. So that just as Julia was talking about, it's about showing all those things. So that slide that she showed, putting the balconies on, there's the cost, there's the time, there's all of these pieces, there's the carbon. So finding a way to have these comprehensive discussions in order to do that. So Taz was the developer that was part of this discussion with us. They were part of our group and they shared this decision-making tree with us, which I thought was really interesting. So starting with design, so all the things that we're talking about, which lower them, really starting with the design, lowering the window to wall ratio, simplifying the form, window details, all of those really being kind of low cost, zero cost items. Once you've done those things, then you go to the innovation. You start to look at things like mass timber, 2D, 3D modular, clip-on balconies. Those are things that generally come with a cost. And then the question that they ask themselves is, are there other co-benefits? Are there savings to time, to cost, to speed? Does it de-risk things? And also, does it advance the industry? A really interesting question, right? We're all in this together. We all have this problem. So if you learn something, I should be able to take that and use that on my project. You've learned the lesson already. It's good, right? So yes, if it has those things, then yes, invest in that innovation. It's good for you. It's good for the industry. If not, then you move to procurement. So all the stuff that Julia was talking about, the things that cost more, then you go to those lower carbon materials. But first, get everything down as low as you can. So same thing if you do with energy, same thing here. So then you go to those low carbon materials, especially concrete, steel, and aluminum. And so those also have costs, but you do that after. So joined up thinking. This is about the integrated design process. My God, we've been talking about this for 20 years, right? But again, taking it back, bringing everybody in at the beginning, a really, really difficult thing to do on residential buildings because of the approvals process, but we're putting this out there again, that as we get to these higher performance buildings, these conversations become increasingly important. So what does joined up thinking look like? So thinking about those 4 levels of underground parking where you've got the number of spaces which are put in place to meet either the zoning requirements or marketing demand. Now that they've taken, some zones of the city where you don't have to put any parking in, now it's really based on market demand. So parking minimums are no longer a requirement in the city of Toronto. We know that parking costs about $55,000 to $120,000 per space. That's insane. That's also 16% of the budget, as Julia pointed out. And then 4 levels of parking accounts for 25% of the construction time. It takes that long to go down and then come back up. So building those 4 levels of parking also accounted for 13% of the embodied carbon of the overall structure. So if we reduce that down to 1 level, we can reduce the construction time, reduce capital costs, reduce those borrowing costs, realize profits sooner, while also reducing the carbon impact. And so then the question is, now can we afford the more expensive envelope? Because we're gonna have to find this, we're gonna have to find the money somewhere. We're gonna have to trade one for the other. What's it going to be? So final takeaways, to get to high performance solutions, we can't simply take an additive approach. You can't just throw solar panels on it and hope it goes away. We have to be judicious in our thinking and really rethink our basic assumptions about design technical systems and the processes we follow to get to these solutions. So it's not all regulated yet, but it's coming. The market is pointing us in that direction. We see how fast these changes are taking place when they take place. Question the business as usual assumptions, even if it's not regulated. Engage technical subject matter experts early, contractors, consultants, clients. Try one new thing on every project, just one new thing. Use embodied carbon tools to measure the performance of your design, investigate what it takes to get all the way there. So if you investigate what it takes all the way there, then some of the stuff that these guys were talking about, which is you're gonna have to decarbonize eventually, find out what it takes to go all the way and then chart the path. Even if you can't afford to do all of it now, do some of it now. Get yourself on the right pathway so decarbonizing over the next 10 years is possible. And check out the carbon. Thanks.
Wow. That's a lot.
It was very
That's a lot.
too, so-
It's really heavy and it's a lot, but hugely appreciate it. I mean, for people in the virtual room and the physical room, I think we're hugely appreciative of the work you've put in, which I'm sure you also all appreciate it's kind of the first step, right? It's an ongoing learning, and I think there's a lot of, I think this is also a bit of a call to action for the room in a way, so that everyone needs to invest in these things. We can't have the 5 or 8 people that worked on this, 20 people probably, do all the heavy lifting. So I think the onus is on everyone here to kind of continue on with this. The point of these events is to really connect people and share. And so if you do run off and discover something, bring it back to the room, bring it back to the group and share it again. I think that's going to be the call. All right, we're going to take some questions. Do we have any online? I mean, the people who are here, but so that, okay, from an equity perspective, I suppose we should include them. But we'll take some questions from the room. If you have any, just put your hand up. I think we have a microphone, which I clearly don't need, but.
I have a question about the costing. Maybe I don't need the microphone.
Yeah.
You had a lot of costs like going up for various systems, but you also had time savings. So was the time savings factored into the cost increase?
Yes.
And so that cost increase was accounting for the time
Accounting
savings?
for the duration of the schedule.
Yeah. So that like 7% premium for balconies, that includes the fact that you're saving a month in your construction schedule.
Yes.
Wow. Okay. Thanks.
Some of the systems that are, especially the glide on balconies, because they're new.
Yeah.
And they haven't been commonly used for most of the projects. they come at a higher price tag.
Right.
The more they're gonna be used, the more like, the repeated pattern, the more stuff they're being produced. The cost is gonna drop down, but it has to start somewhere.
The unfamiliarity premium.
Exactly. And it's like the premium coming from the installer side of it, because they need to learn the process of the pattern.
Yeah.
But also from the production side, what works better. The first one is gonna be probably the most expensive.
Yeah.
But that's what we're landing off.
I mean, you could almost challenge it by saying, through the sort of joined up thinking model, is there a way to do balconies that are perhaps inset as opposed to outbound? Is there a way to controlling thermal bridging in that way? Like I know RDH and others have worked on some of these details on the West Coast. Like, maybe we should get them to share some of that. Is there a way around some of these things? Because balconies seem to be, it's a market-driven factor, very much so. And so, how do we do that without having the outies everywhere, right?
Well, and the issue with the innies is that you have more thermal bridge,
Right,
right? Like,
yeah.
so unless you're gonna have point supports.
Right,
And then the other thing is, we say the market says you need balconies, but then look at the window
Yeah.
and like, how many people are
Yeah.
on the balconies, right? So,
yeah.
so we
Challenge
say
it, right?
we can't, so this is the question of business
Yeah.
as usual thinking.
Yeah.
If you're on the 60th floor, does there need to be a balcony? Or
Right.
do you need access to outdoor space and
Right.
access to nature? Those are the things you need those qualities. But you don't necessarily need a little tiny balcony that you can only put a chair on. So
Right.
it's question it and design something better if it's not gonna be that, right?
I mean, it's, who was it the other day? Nama Blonder was the other day, was like, my backyard is better than your backyard. And she was talking about access to parks, living in cities, access to parks, rather than sort of having a backyard need to maintain, like a physical backyard in a single family home. So thinking about shared space, investing in the shared spaces as opposed to investing in balconies, is kind of flipping it on its head and challenging the marketing. Anyway, I digress. Other questions in the room? Yes, go ahead.
Okay, this was awesome. I don't think the applause was enough for what you've done, so just want to magnify that. Question, Brandon, you showed the carbon tax, and at least where I am, I find clients often don't understand what's coming with the carbon tax. And I admit, I maybe was not totally focused when you flashed that up there. So were you actually talking also about embodied carbon when you were no, right?
No, just operational.
Just operational.
Yeah, that's
Because,
right.
like Emily, remember we were talking a while back about TAP had done a report and they had showed that clients often, it's the financials that are murky. Like all of this, it's all fitting together, but it really ends up boiling down to the financials. Now, are there tools out there to help us with the industry that are clear and easy for us to use? Right, because carbon tax is something real and it's scary. There's many things that are scary that are coming, but the financial aspects, how can we as building professionals help to make that clear?
Yeah, I think an exercise we did, these numbers are gonna be a little out of date, but air source heat pump makes sense, like for the forecasts of carbon tax and an equal inflation of natural gas price and electricity. Those in Ontario are anticipated to make sense by 2030 tax. Geothermal makes sense by 2025. So basically every building being built now is gonna have an operational economic, like some positive ROI associated with that investment. So I think just like using simple things like that, like yeah, maybe it doesn't make sense quite yet, but it's going to for every building that's being designed and built.
Is there like a tool out there that I can like show and like, yeah, look, RWDI said.
Yeah.
Can you publish whatever you just said?
Yeah, sure,
Yeah,
yeah, I'll
Yeah.
write a little blog post, yeah.
Yeah.
Thank you.
Well, I took an energy model thing, I think you guys had done in the project you guys had designed, and we were trying to get the client to do geothermal, and they couldn't find the business, and it was bothering me so much that I actually the project slowed down for me. I went back and I looked at the energy model, and I was like, okay, this is how much the gas is, this is what they're gonna use every year, this is what they're gonna use for, and I just took the carbon tax and did the math on 5 years to find out what it would cost, and it was gonna cost them about $1 million in, over 5 years in carbon tax. And I was like, do you see, you know, so we ended up, I think you checked the math on that, so I wasn't sure.
Yeah.
And so I took it back to these guys and, you know, it's something that now when the project starts back up, we'll share that with the owner, but it was interesting to go and break it down, there was enough information in the energy model, and then I just made a little Excel up and shared it with the dollar values of how much it's gonna go up year over year. So it's kind of interesting.
I think an interesting nuance there, Michelle, is also thinking about developers developing for condominiums and stratas versus rental development. I mean, affordability, as Julia pointed out, is going to be the thing we're really going to come up against critically. And so as a country, we've kind of fallen really behind on rental as an industry. Like we're about a generation behind on providing rental, and especially like from my time on the West Coast, we were learning that when you start laying out your pro forma and start then applying the carbon tax to your pro forma in terms of your revenue moving forward. So going beyond the construction and the transfer, as you would on the sort of condo side of things, if you start looking like from an asset management perspective, an operations perspective, it's that much more urgent. And we were finding that rental developers and things were the first to the table when passive housing thing was started. Like when the step code came out, most of the initial applications coming in were rental facilities because they were understanding the skin in the game when it came to sort of the carbon side of things. And so that's something that's also we have to consider. We're going to be not doing perhaps as many condos because just surely from purely from an affordability perspective, but the rental side is something that's going to be a huge part of the market in the next 10 or 15 years, and they will be very interested in the carbon tax. And that's, our carbon tax here is actually quite modest compared to what they're doing down in New York. And so, like the way the TGS kind of goalposts have changed, we can expect that to happen on the carbon side too. Like 2030 isn't that far away.
Yeah.
Go ahead.
I was going to give some anecdotal information based on a chunk of jobs that we've done, and it's interesting. I'll talk to the market condo and then the rental. So the market condo, we're seeing a lot of geothermal. We're biased because we're also trying to sway people that way.
Yeah.
Obviously. So the data is biased based on what's happening in the market at large. But the utility model geothermal has really helped. And I love the fact that that's convinced people that don't know what the utility model geothermal is. It's the third party that comes and builds and installs and operates for a fixed fee, right? And it's all predicated on the fact that the condo owner would pay no more than they would have before, right? So it's offset by utility costs and all that. So it's very encouraging that the private sector, even the non-impact developers, are doing that because it just makes financial sense, right? And that's helped the impact developers saying, look, it's not a new technology, or take away a bit of the fear factor that we're seeing in the industry as well. On the rental side, what we're seeing is in Ontario, current carbon tax market and all that, we're seeing a lot of them that even if they can't pull the trigger on deep carbon reducing technologies because their pro forma can't afford it, they are very interested in how to convert in the near future, not end of life or mechanical, but even the day I open, if I need to rip out this boiler with heat pump, I need to know my building's ready for those reasons.
Yeah.
And so we're seeing that today. I'm doing some for some institutional buildings, and that's how we're looking at it. We're saying, okay, this will be kind of the separate price. We'll play that game, right? Can we afford it? Can we not? But what has to be there is everything below the plant has to be zero carbon ready today, extended range heat pumps or whatever that means, because I can't afford the penalty of not having that ready by just replacing a few things in the penthouse.
Michelle, you wanted to add to that?
I can't remember where I was going.
There's way more profound than this.
Yes.
We all missed it.
No, I was actually, you know what it was? It was about the, rental, we know what makes sense. I think this group came together out of the frustration of what was happening on the condo side. So because that 90%, 89% of them were condo, and it is the harder discussion. It is the capital costs that we're after. It's when you're working with a developer who's thinking about capital cost only and not about operational costs, it makes it very different. And so the question we put to ourselves is, what can we do now? What can we do? Like lining up structure, there's no cost. In fact, it's a cost savings. We did it on a project we just studied where we did all independent columns, and we did some, just minimal shear walls. And we did it not because, we wanted to do it because of low carbon, but it was actually driven by formwork costs. And it's like often the cost and the carbon costs are in alignment, especially on the structural side. If anything, some of the stuff that we struggled with on the structural side was whether the trades will do that for you, like
Yeah.
the post-tension.
Yeah, the post-tensioning, like that's a limit here. I don't think there's very many trades that do it, so that's gonna be a cost premium. But then, yeah, on the formwork side as well, like we love our shear walls here in the GTA. And, that seems to be driven from the formwork trade perspective, but that is having a huge cost and carbon impact. But yeah, for structure, especially for concrete structures, like it's very clear you see a huge reduction in your volume of concrete, that translates directly to savings in construction.
And I think part of it is if we're all telling the same story, if we're all saying we have to get there, we as professionals want to get there, it's our responsibility to get there, we're putting up this stuff, these decisions we're making today are impacting it for 60 to 100 years. We want to be having these conversations on all of our projects.
Absolutely. Any more questions in there? Bless you. Yes, please.
Yeah, I had a quick question. I also want to know, thank you so much to our speakers. It was fantastic information as well as the organizers for this event. But I do have questions because I know mass timber was brought up on more than one occasion. And I just wanted to know really anyone from the panel's opinion about, I guess specifically some challenges that we're seeing, especially with regards to mass timber and tall construction and tall MRFs, as well as maybe what kind of changes we're seeing in the industry to kind of accelerate our change towards more acceptable mass timber practices in the tall building industry.
So there are some limits in terms of height just based on code, if you're following the code approach. So I mean, for a 40-story tower, being able to get that out of completely mass timber, likely not gonna happen. I'm not gonna say impossible because anything's possible. I love mass timber. But there's hybrid solutions. Like definitely, I think, there's lots of opportunities for us to be incorporating mass timber a lot more into design than we already are. And likely through hybrid design. So looking at where is the most optimal place to be using mass timber in building versus using concrete or steel. So it doesn't have to be, this is just gonna be a concrete building or it's just gonna be a mass timber building. It's like, let's look at which materials work the best for which elements or which systems, really optimize them for that, and then come up with a hybrid system that's gonna work the best. But there certainly are mass timber buildings that are much taller than, what traditional code would allow. You just have to go with an alternative path to do it. But definitely seeing quite an uptick, at least in demand for studying mass timber as an option on projects. Sometimes it does get costed out, and that's a whole other discussion on is mass timber being costed fairly compared to other construction, which I think a lot of folks might say no, it's not in certain ways. But we definitely are seeing a lot more interest from building owners wanting mass timber incorporated into the designs to a certain extent. I'd love to see that more in NERVs, but yeah, I think there's probably some hurdles that we have to figure out to get that to work.
I'd say also with the code change last summer, so July of last year, being able to go up to 12 stories in encapsulated mass timber. So we are working on 2 at the moment, they're early stage, which is kind of exciting. We have yet to do an embodied carbon study on that, we will. But even with that, it's that cost premium for doing it new. It's, those parts are all gonna come into play. There is more mass timber happening on the commercial side in the city, which is really exciting to see because it's starting to grow. But if you look at the maturity of the industry, where concrete is here in terms of maturity, mass timber is still down here. So it's not just the mass timber providers, but it's all those other trades that are learning what it is to work with mass timber. Like when we did 80 Atlantic, we built 1 bay of structure at the Carpenters Union, and then we had them install the curtain wall. We had them install all the different pieces around it, the sprinkler system, all of those things, so that the trades could understand what was going to happen on site, and it does slow things down, and it is new, and so I think it's coming. It's just going to take some time, and it's a risk, right, for the person who's trying to be the first out of the gate. But I think, again, you're gonna see more of it, because if you look at those embodied carbon numbers of where, once those become mandatory in 2025, typical concrete solutions, so you had the different pathways, the practical pathway and the ambitious one, I guess, there was another word for it. And then it's the what comes next, and the what comes next is thinking about hybrid systems and
Yeah.
stuff like that. It's going beyond concrete.
And I think we'll start to, once we see more of these projects come to fruition and get a better sense of like, what are the schedule savings that we're seeing for mass timber buildings, like that's gonna help to build that business case for going with them. But yeah, it's funny, it's like we've been building with wood forever, like we know how to do it, but it still seems like it's, currently it feels new to everybody, so, but yeah, I think once there are more of those in place, more business cases to demonstrate like this does work. It can be less expensive or cost comparable to conventional design, and that's gonna really help drive it forward.
All right, where are we? Almost there. Any final questions? Anyone online? Questions or?
There is a question.
Okay.
Any concrete experts in the room that can speak to global warming potential impacts of admixes to meet earlier set times?
Question, I don't know the answer to it. Whether, yeah, I know that is something that, I mean, from what we've seen, we've looked at, it doesn't look like admixtures have as huge of an impact, like we know Portland cement is like the big player. But it would be interesting to see, to hear from someone like Large or others on if they've studied the global warming potential of the admixtures they're putting in, especially for mixed.
For context, Emily, what's the difference? Like is it twice as long going low carbon or
In terms of set time?
Yeah.
Well, so if you're going, it depends on the mix. It
Okay.
really depends on the
Okay.
mix. So EcoPact, like for their entry level product, where they are using, I mean, it's a proprietary mix, but increased SCMs, so then admixtures to offset the impacts of set time. That would have the same set time as a conventional concrete.
Okay.
They made that so it's very easy for designers and contractors to put on their projects. Once you get to higher percentages of SCMs, it's recommended to change your concrete design strength from 28 days to 56 days. Not to say that it does take double the time to achieve strength, but just to give that additional space to meet the spec requirement. But it's really going to depend on the mix.
Right.
And there's ways to get around it, and it might make more sense. Like I love Michelle's point of like try something, just like one new thing on a project, like one low carbon measure on a project. And so it could be for your structure, like maybe just go with your higher SCMs in your foundations. Don't worry about everything else. Like maybe just focus on foundations where you might be able to get away with having a longer time to achieve strength. But it's really you have to have that discussion with the team, ideally with the contractor, to talk about how it's gonna impact schedule, but it does depend on the mix.
I was gonna mention for floor plates in like 7,500 square feet.
Yeah.
The typical forming cycle is 3 days.
Right.
You need to cure the concrete in less than like 2 days to strip the forms. And the moment you add high-early to the concrete, no matter what's EcoPact or whatever like concrete you're using, the carbon footprint, we are lowering that already because that it's offsetting the carbon dioxide in the concrete. So the schedule, if you need to like lower this, they get the schedule from 3 days to 5 days to strip the concrete, but the concrete is 75% of their strength. So on every single floor, I'm adding 2 days.
Right.
It adds on the schedule a long time. So cost-wise, on the end of the day, it's not gonna be less, but just like make sure that the decision should be cautious decision at the beginning. You're gonna have a longer schedule, but in the longer schedule and the cost impact, you're gonna give back to the environment and like lower down the carbon footprint.
Yeah, I mean, you can kind of flip that as well and be like, are there other parts of the building, or like say like like to offset that extra time, like is it a prefab facade? Like how else can we get really smart about it? We want to do this thing from a carbon perspective, and then how do we offset it through saving time on something else, perhaps?
I would just say, like, everyone said it right, like, every single floor up to the podium, when you have like bigger floors, like floor plates, and you don't have to fill forms and you don't
Yeah.
have the like short cycles when you have to, you need your 7 days or 5 days securing time. That's a perfect place
Right,
to
yeah.
use the concrete, and you have the bottom portion of the building has the most massive of concrete, so at least like you can save 65% of it as a equal impact or equal impact concrete. It shows, well, that's the first step.
Yeah, it doesn't have to be all or nothing. I really like the idea of like introducing low carbon materials, like piecemeal maybe at the beginning to at least get folks comfortable with it, trying it out on projects rather than be like, oh, it has to be all or nothing. But for the admixtures question, I'm kind of get rid from that a little bit, but it would be great to find out more about admixtures. Hopefully we can pull off
Alright.
an approach.
Okay, all right, well, on that note, I think we're gonna end the presentation here. We have some snacks at the back. The speakers are around, you can ask more questions. If they're up to it, you know, they've been sitting up there for a while. But a massive thank you to, well, firstly, Multiplex for hosting us. Thank you for having us here. For all of our panelists who are also our sponsors tonight. So thank you all for your time, the effort, of course, into this, but your time, especially to come here and meet everyone and present this. It's extremely well put together and really excited to see where this takes the industry. So thank you very much.